but it's still expensive. In Indonesia, for one station data streaming is about $200 per month. $200, but for GPRS $6. This is $200. You can see the difference. And it consumes power as well, more power. But for this, it consumes less power. Any question?
Excuse me, sir?
Yeah.
What kind of microcontroller do you use?
This one? ARM.
ARM.
Yeah, IRM. Yeah, there are many, but it's quite popular here, ARM. So if you are familiar with GitHub, you can get open source program there.
Is it possible to use like Arduino or
Yeah,
Raspberry Pi?
Raspberry Pi, yeah. But it's quite, if you use Arduino or Raspberry Pi, it means you rely on their module, right? Yeah, it's good for new starter. Yeah, but if you would like to control yours, everything, you should go to make this printed circuit. But now, I think it's progressing. Now they like Arduino is going more. If you use Arduino, the layer is quite thick, right? But now they provide more solution, better solution. Yeah, yeah. XB, yeah.
I have a question.
Yep.
I would like to ask data gadget.
Very good.
Is radar gadget able to measure light when rainy day or high sky?
Yeah. Yeah. Radar gauge. Radar is quite expensive, but with some you use ultrasonic. Ultrasonic. Yeah. Radar. No worry, because the distance is about 2-3 meters. So the weather slightly affect the propagation. But if you have like altimeters long way, 800 kilometers, yeah, the weather will affect that. So that's why you have to model to correct that effect. So this is about, this is one of what. The maximum distance for ultrasonic sometimes only 10 meters. 10 meters, so you can see the distance. Yeah, you can assume it's quite similar. Even in the rainy days, not much different. Yeah. But if you only the accuracy about 1 centimeter water level, yeah, yeah. You need the accuracy of water level is how much? What do you expect? Millimeters? Yeah, centimeters, 2 centimeters is good, right? Because the water is splashy. Right. Okay. This is it. Unit programming here. Android based. So if you have to control this command setting, if you have you have your sensors, your data logger here. Yes, this one. How you control it? You can use your laptop, right? Setting. But it's quite complex. Why do you have to use laptop in the field? You bring this. Everything setting. Android based. So Android programmer quite expensive now.
So
Yes.
you should have a web hosting also?
Yes. Web hosting now is quite easy. You don't have to set up your own server. Buy cloud. You know, the cloud, it depends on the size that you rent. It can be $100 per month or 500. It depends on. It's like a Gmail, right? You can get free. You can get, if you want extra, you should pay. That's all. Thanks for a server, cloud server, right? That's it. So for computer science, they have a very big opportunity to do that. So you learn. Yeah. So like oceanographer, they should learn computation. Don't rely on IT people. It's quite difficult sometimes. If they don't have oceanography or earth science background, they do programming, you have to train them, explain them about 3 or 6 months. You spend time to learn. But you are trained, if you have a oceanography, you do a master degree on IT, you are much faster, to be honest. Right. So this is great opportunity, multidisciplinary. So this is how human interactions involve this. Yeah. So if you make your program, your display, if the people don't understand, they don't like it, people will not buy. They are not happy. Right. This is it. So this is what you have to put. So this is Internet of Things. Your sensors here, yes, everything's in this box. You see it there, and everything could be. There are so many actions using mobile phone, using radio, or using satellite. It depends on your opportunity. It depends on the area. It's like in Taiwan or in China, mostly, or in Thailand, but in Indonesia, in Korea, you can get it. The coverage of GSM are good. Is it? How about the coverage of GSM in Korea? All along the coast. You can get the signals everywhere in. Can you get the signal everywhere in Korea, in coastline of Korea? Yeah, right. Yeah, in Indonesia, in the easternmost of Indonesia, many parts, even in southern Java, GSM coverage. So this is the beauty. Yeah, to get data, this is cheaper. Yeah. So this is what the example what we did for safety navigation. What we call toll road, not toll, toll port, toll out, sea toll. Yeah, toll out, sea hub. Yeah, sea hub.
You understand?
Of Indonesia, because the price of merchandise or the price of petrol or foods are very much different here from island to island. So our government decided to have a regular shipping line to reduce the cost of logistics. So that's why this is the toll road, toll port, what they call regular port. Yeah. Right. 49. The price. So they have to buy this one. And it is should be like this. So they can monitor. This is still simple, but they should incorporate this data to their BTS. Yeah. Yeah. Tarempa. This is Natuna. This is there's a regular zip lines here from Jakarta. This simple, so they can monitor. So, how to do troubleshooting when you have a tight station, your monitoring system? First, there are some factors. There are bugs in your firmware. When you know firmware is software installed in your hardware. That's what it's software. It is software. Why? Another factor is physical changes in the sensor position. It means like this sensor is not going down, but it's because of wind, it's going somewhere, right? Physical changes. Or it was obstructed by wind. This pole was obstructed by wind. Any physical thing. You should interrogate it. You should investigate, if possible, remotely. Don't disturb your local operator. Sometimes he complains, oh yeah, I'm just doing a simple job, right? Add it to his task. They are from the port authority. But if you ask more and more times, you will disturb him doing his regular job. Okay? There are some obstructions. And the method, you investigate from monitoring display. Right? Okay, what's wrong? Just jump over. Yeah? And or you can do soft rebooting by sending remote command via SMS command. Yeah. You have facilities to do that. If your data logger is smart enough, so that's why you have to build your smart data logger. Yeah, to accept this SMS command, rebooting. Sometimes you need rebooting. Even your laptop, even your mobile phone, you need rebooting, right? It's not reliable all the time, right? You need rebooting. Yeah, it's like your friend as well. You need rebooting him, right? Importing him. Yeah. What's the problem, right? This kind. Yeah. Then you need force rebooting. Yeah, force rebooting. How? You can set up this one. If you ask restarting, right? Restart. Oh no result. Then you do force rebooting. How would you do the force rebooting? You open the battery, right? Okay. Put again. That's it. So in the power system, yeah, this one. Yep. Force rebooting. Dismantle the connection from here to this. Is it? Right, check. Pull up. Cut. This one. Or that, yeah.
How many days stays safe? How many days?
How many? Oh yeah. You see, this is how much is 16 gigabyte. So it record more than it can record the data 7 years continuous. It's more than enough. 7 years data.
So when the trouble was retired,
Yeah.
The data can
Yeah.
photo
Safe, yeah. But then you have already transferred the data directly to the web. It's on there. But you need backup on your system. You have memory card there. Backup to backup, sometimes. But once you You send the data, it's already there, it's copied by copy to many persons. Yeah. Right. If no chance anymore, you have to do physical repair, easier repair, right? If you were to force rebooting, no more, no chance, you go to the shopping mall, ask somebody to repair. If they couldn't not do it, then what you do? Throw it away. Yeah. So, data validation. Sometimes you need a jump to your data. Yeah, right? But the first stage, yes, here, what I'm saying, synchronization of the reading from here to the tide stub. You see, the tide stub is, let's say, 8 meters, 8.00, something like that. Here. Right? But the reading should be harmonized, should be converted to 8 hertz. See, right? From here to here. So you set up that. Offset. You offset. You introduce offset to your system. Somebody asks you, you read the tide stub, right? Okay, 8.00, you read many times, at least 3 or 5 times, right? You are convinced. Do it fast, because the change soon. Then you introduce offset to your system. So the reading would be 8, the tide stub reading 8.0, something like that. The reading introduced to the website should be 8.0. Yeah, right? So you synchronize them. Then you check that regularly. But now the simple one is you ask the operator is WhatsApp, right? Camera. Okay, take photo, yeah, and send it to us. Okay, you see, you read from the internet, from the website, or you're reading, oh yeah, similar to that. There is a delay, but not significant, right? Because you, from the photo, you got the timestamp, yeah, of when it's recorded. Then you check from the, in the past, from the web. In the past, it's a laborious work. We had to introduce like a switch, Tidal switch, what we call it, introduce in the tide stub, control it here. So here we add more sensor here. When it's up, it's recorded. When it's up here, it's recorded. So we have like a control. When the reading here, so we see the check. When there is a drift, we can see that. But now it's okay, no problem. It's continuous, right? Because we have a data stream here. You can see the continuity of the reading. Yeah. So to make sure, sometimes you need to ask the operator to take photograph to the tide stub with the water level on it, right? Check. Okay. It's like you read it directly, but you do it remotely with photograph, right? So no worry about it. It's overcome with the real timeness, right? This is very important. Okay? Yeah.
How often do you need to do stuff reading?
Yeah, just on. What? No, not too much necessary actually. Yeah, because you can see when you measure tide, you measure the shape of that, right? Yeah, what's this? Actually, you don't need actually tide stub. You just measure that, and then you refer it to the. You then can refer it to the tide stub reading later. But I think you have to make sure from time to time. It's like a quality control. You do regular quality control. But because you do it real time, you see the continuity of your observations. But when it jumps some discontinuity, you should check it. That's what you need, but not regularly. But you just check. Oh yeah, you can introduce warning there from your IT people. Just check. Okay. Okay. Make it automatic. Right. That's the beauty. So IT, you have to cooperate with your IT. Make sure. Don't do laborious things. It takes time. So thanks for the IT, Internet of Things, and digital sensor. Accurate. So you can buy your accurate sensor anywhere. High quality. Right. Yeah.
Parluhutan,
Yeah.
did you or do you put ellipsoidal heighting on the SOP nowadays? Are you programming that now? I mean, if you install your station,
Yeah.
if you do also GPS survey of the for the heighting, are you going to do that, or is it necessary to do it? Because for the purpose of unification on the
Yeah.
ellipsoidal reference.
So that's what. Thank you, Pak. We will talk about this
Now.
soon. Yeah, now. Yeah. Tidal datum. You know this from your past lecture, right? Yeah, from Pak John. You know, I just refer this. What? This is tidal datum, right? You know, you need to know this. Yeah. Lowest observed LIP. That's for chap datum, right? But for what do you call it? Fishing industry, you need to know this one, right? And then for boundary demarcation, or yeah, you need to this one as well. Mean tide level, different application of this one, right? But different definition. West Coast, how to get this one, right? But normally, based on statistics, we refer to LAT. Yeah. But Pushidros, they have your own definition for that.
Low water spring.
Lowest water spring. LWS. Yeah. It depends on your assumption or what you believe, right? But so long you can convert it to others, no problem. Yeah. Right. So this is connection from tidal datum. Tidal datum is abstract, right? It's computed, right? It's not physical. You cannot find it anytime, right? It's changing, right? But you can mean sea level. So you have to realize it or to make it real, to connect it to this one, to the benchmark. Or Pushidros said it, the benchmark hydropilar. They have their own words. I like that, hydropilar. Yeah, yeah. This one. So now Indonesia introduced standardized benchmark, guys. SNE, Standard National Indonesia, Indonesian National Standard. They have the standard, the size of that, yeah, the depth, the classification. First class, they have their own standardization. So we do measurement from benchmark to the tight start, right here, to do this. It's more easier now to do this leveling. Yeah, you do automatic leveling. It's easier, right? Like this as well. This is automatic leveling. In the past, when I started my survey life, it took a long time with optic one. In a rural, like in Kalimantan, in Borneo, it's bumpy, right? I did it. Oh, it's not fit to the quality, right? Oh yeah. unacceptable, rejected many times. When we do measurement leveling, even it's in the early morning, but there are trucks and pass by, oh, it's not fit. But with this, we can do it faster. Thanks for the technology. Yeah. So your life is easier now. I'm jealous. No, so this one, the tile stop to this one. So in the past, we have our own height system. The benchmark in the past, because the measurement type is quite different. To have precise measurement with height, you use leveling, right? Then to have horizontal coordinate, you do total station. So in the past, there are two pillars, height pillar and horizontal pillar. But now we got it three-dimensional. So what Pak Purbandono mentioned, Pak, we do precise GPS measurement on this pillar. So when you do local connection with this simple observations, we cannot do GPS observations here, right? It's difficult. Or if you have side pole, it's not precise using kinematic. So we better do this one here. So we have a millimeter precision. So when we have this pillar coordinates very precise, so we can unify datum from this place to this place, connect it. Because each station, it has their own tidal datum, right? Right? Datum, reference height, right? So, because of the gravity, Pak Mariono mentioned that yesterday, it difference between one to this one another place. Yeah? But we call it, if you go from here to here, the mean sea level between northern Java and southern Java is not the same. There are, what the difference is sea surface topography, right? So between one tidal datum to tidal datum, you need to unify that. What Pak Purbandono mentioned. So you have to measure your hydro pillar or tidal pillar precisely, right? So just do this simple one to this one. Close. Yeah, this is an assumption. Everything in the Earth's surface is not stable, right? Don't assume it's stable. It's changing world. It's a changing Earth, right? Deforming Earth, right? Right. This is it. I got this from Professor Abidin. They have their work. I read it. I started leveling measurement in my first career in this area, in Jakarta. Yeah. Subsidence. Right. So physical from USGS in San Jose, San Jose. In 1925 is at this height. But then in 1972 at this height. Because it's you can imagine this. Oops. How many times? Even in Jakarta, how many? How much? The rate, 15 centimeters per year, 65 centimeters. The rate is 10 centimeters per year.